13.2 Line Integrals, Video 4. Let's do a simple example. Let's evaluate the line integral over the curve C of 2x ds, where C is the parabola y equals x squared from the point 0, 0 to the point 1, 1. Let's start by sketching the curve that we're integrating over and defining it parametrically. You all should know what a parabola looks like. But we're only looking at the portion of the parabola from the origin to the point 1, 1, so we can get rid of the rest of it. And we'll define the orientation from the origin to the point 1, 1. But we don't have to define it that way. A line integral is actually independent of the direction, but we'll worry about that later. Okay, so we need to parameterize this. Since the equation is a function of x, we can parameterize this by saying x is equal to t and y is equal to t squared. Now, alternatively, you could just say x is the parameter, and not bring in a third variable. But I like to always use t as a parameter, even if I'm defining one of the other variables to just equal t. And what is our range of values? Well, at the origin, t would equal 0, and at 1, 1, t would equal 1. So 0 is less than or equal to t is less than or equal to 1. Now, if we're going to find our line integral, we need to set up the differential. So we're integrating from t equals 0 to t equals 1. We'll change the x in a sec. Let's change the x now. What does x equal in terms of the parameter? T. But for the ds, we need the square root of the sum of the squares of the derivatives of our parametric functions. So inside of here, we need to take the derivative of what x equals and the derivative of what y equals with respect to t. So dx dt goes here, dy dt goes here. The derivative of t with respect to t is 1. The derivative of t squared with respect to t is 2t. And now it's become a calculus 1 integral. So let's evaluate it. Integral from 0 to 1 of 2t times the square root of 1 plus. We have to square both the 2 and the t, so we get 4t squared dt. This is screaming substitution. So we're going to let u equal 1 plus 4t squared. And as a consequence, du would be 8t dt. Okay, so the radicand will become a u, and we need the rest of the stuff to become the du. Well, we've got the dt, and we've got the t, but we have a 2 and we want an 8. So to make an 8, to turn a 2 into an 8, we would have to multiply by 4. But we have to balance that with a 1/4. So our integral becomes the integral of 1/4, the integral t equals 0 to t equals 1. I don't like changing the limits of integration personally, so I'll leave them, but they're t values. Everything underlined becomes du. So du. The radicand becomes u, and it's in the square root, so it's to a 1/2 power. So this is an easy integral to evaluate. Raise the power by 1. We get u to the 3/2. Divide by the new power, or equivalently multiply by its reciprocal, so 2/3. And then we have 1/4. And we're going from t equals 0 to t equals 1. So let's multitask here. Let's put together the fractions to get 2/12, which is 1/6. And at the same time, let's change the u back to 1 plus 4t squared. And that's all raised to the 3/2 power. And this is from 0 to 1. I can remove the t equals since it's the only variable now. If I substitute 1, I'll get 1/6 times 5 to the 3/2. And if I substitute 0, I'll get 1/6 times 1 to the 3/2. And at this stage of the game, you're expected to simplify things completely. 1 to any power is 1, so this subtrahend, minuend, that's the second part of the subtraction problem. I think I always come backwards. The second part of the subtraction problem is just 1/6. But as far as the 5 to the 3 halves, you're probably obligated to do the following. 3 halves is the same as 1 and 1/2. 1 and 1/2 is the same as 1/2, 1 plus 1/2. So you could break this down into 5 to the first times 5 to the 1/2. Well, 5 to the first is 5, and 5 to the 1/2 is the square root of 5. So we could say 1/6 times 5 square root of 5 minus 1/6. Hey, look, common denominator, might as well put it together. 5 square root of 5 minus 1. So it's a little messy, but at this stage, messy is not an issue. You deal with it. All right, in the next video, we'll talk about doing a line integral over what's called a piecewise smooth curve.